Hey everyone, welcome to today's Explainer. So, if you've ever found yourself just staring at a screen full of Haskell code, feeling like your eyes are crossing while you're trying to figure out what exactly happens first, well, you're absolutely in the right place. Today, we're zeroing in on a highly focused but honestly incredibly powerful goal, making your Haskell code instantly readable. To pull this off, we're going to dig into some really fascinating programming notes published by a developer named Ang. Specifically, we're looking at their 187th entry on Haskell programming from July 15th, 2026. Let's jump right in.
I want to kick things off by having you ask yourself a kind of tough question. Is your Haskell code actually readable? Really think about it for a second. When you or maybe a teammate opens up a file, what's the actual cognitive load required to understand what a function is doing? Now, obviously, we write functional code bases because they're elegant, they're safe, and they are mathematically sound. But let's be real, sometimes deciphering them requires some serious mental heavy lifting. We all want that direct, immediate understanding, and honestly, standard syntax sometimes gets right in the way of that.
Section 1. The Readability Challenge.
Okay, let's dive right into this. This brings us to the primary frustration developers face with standard Haskell function composition. And this is exactly what Ang set out to solve. You find your eyes constantly bounding back and forth just to parse nested functions. It's like, imagine trying to read a simple English sentence, but you have to jump to the very end to read a word, bounce to the middle to catch another word, and then jump all the way back to the beginning just to figure out the subject. It's exhausting. That bouncy, erratic, and confusing rhythm is exactly what happens when you use traditional right-to-left function composition. You know the drill. You start on the far right to find the input, you evaluate it, then you move left to the next function, evaluate that, and on it goes. It just creates this tremendous amount of completely unnecessary mental friction.
Section 2. Enter the Flow library.
Enter the Flow library, which is absolutely the hero of our story today. So while Ang was exploring how to write more readable Haskell code, they actually stumbled upon this gem in part 187 of their programming notes. Basically, Flow is a library that provides functions and operators specifically designed to favor a left-to-right composition style. It just makes the code so much more understandable. And the absolute star of the show here is the .> operator. Before we even look at any code, just visualize that symbol in your head for a second. A dot and a greater than sign. It's literally an arrow pointing to the right. Inherently, just visually speaking, it suggests forward momentum.
Section 3. Refactoring function composition. So, purely out of curiosity, Ang installed the Flow library and ran a tool called HLint to get some recommended suggestions for their codebase. And the visual diffs that came out of this transformation show us exactly how powerful this operator is in the real world. If we look at the standard Haskell version, we have either, and then in parentheses, pure.left, applied to f. That standard dot operator completely forces you to read the inner composition from right to left. So first the left constructor happens, and then that result gets passed over to pure. Now compare that to the Flow library version. We have either, parentheses, left dot greater than pure, applied to f. By just swapping out that standard dot for the dot greater than flow operator, we immediately flip the reading direction. First left, which then flows directly into pure. It transforms into this straight logical path that perfectly matches how we naturally read text.
And this brilliantly illustrates the true power of Flow when things get, a little bit more complex. Let's trace the journey on the standard snippet. You've got pure dot, right dot, BL dash from strict, dot encode UTF-8 $output. Okay, to actually understand this, your eyes have to jump all the way over to the right to find the output. Then you pass it left to encode UTF-8, then pass that result left again to BL dash from strict, and so on. It's a lot of jumping around. Now follow the smooth, continuous left-to-right flow of the new code snippet using Flow. We take the output, pass it into encode UTF-8, dot greater than into BL dash from strict, dot greater than into right, and finally dot greater than right into pure. It is a journey that actually moves forward. You're reading it in the exact same order that the data is being transformed.
Section 4. The Data Pipeline Mental Model.
So what does this all mean? What we're really doing here is shifting our focus from a micro-level syntax change, like just swapping out a dot for an arrow, to a massive macro-level paradigm shift in our mental model as developers. Think of it like a universally understood engineering metaphor, the classic assembly line. Step 1, you have your input. Step 2, that input flows smoothly into function A. Step 3, that result flows right into function B. And step 4, boom, you get your final output. This left-to-right flow is just so much easier for the human brain to process because it perfectly mimics how physical processes actually work in the real world. You start with raw materials and move forward through an assembly line to get a finished product. I mean, you wouldn't build a car by starting with a finished vehicle and working backwards, right? Our brains literally crave that forward progression, and this syntax gives that natural momentum right back to us.
Section 5. The Elixir connection.
This is where Ang had a really fantastic realization about how this specific mental model translates beautifully across different programming languages and why certain developers might find this particularly liberating. I absolutely love this note they wrote while analyzing the results of the refactor. They said, definitely, especially for those coming from Elixir background, which favors data pipeline or left-to-right style coding. At least you don't need to bound back and forth to parse nested functions. The Flow library isn't just some neat little party trick, it actually serves as a perfect bridge for developers transitioning from languages like Elixir, which, is super famous for its pipe operator, into Haskell. It allows them to maintain that highly efficient, readable data pipeline mindset without getting totally bogged down in traditional, nested Haskell functions.
Which leads us to our final question for today's explainer. Is it time to shift your mental model to the left-to-right pipeline? I really challenge you to go look at your own functional code bases today. Look at those deeply nested functions and those really long strings of right-to-left operations. Just ponder for a minute if adopting this data pipeline mindset and maybe utilizing a tool like the Flow library could save you and your team from constantly bounding back and forth just to read your own work. Thank you so much for joining me for this focused look at Ang's notes, and keep streamlining that code.